This is an instructional video on the introduction to probability. What is probability? Probability is how likely something is to happen. Probability can be measured using numbers from 0 to 1. A probability that is close to 1 is more likely to happen, and a probability that is close to 0 is less likely to happen. Use the following fractions to help you calculate probability of a simple event. And you probably will remember probability from elementary days or even maybe 7th or 6th grade. So probability is equal to the number of favorable outcomes over the number of possible outcomes. So imagine you have a bag of 16 sour candies. 2 of them are going to be lemon. Calculate the probability that a randomly selected candy will be lemon. Make sure you simplify your fraction. Always simplify your fractions. So when you look at this one, you have a total of 16 possible candies, and the one that is favorable is the 2 lemons. So that's where they came up with their fraction right here of 2 over 16. 2 over 16 needs to be reduced, so you can divide the top and bottom by 2, which brings it down to 1/8. So the probability of randomly choosing a lemon candy is 1 over 8, or 1/8. Since 1/8 is close to 0, it is unlikely that you're going to be able to randomly select a sour candy that is going to be a lemon. Here we have an example problem to work with. Find each probability. Write your answer as a fraction in simplest form. The drama club at Lee Middle School is deciding on their spring production. There are 25 students who want to do the musical, and 5 students who want to do a play. What is the probability of randomly selecting students who want to do a musical? So this statement right here is just the probability of the musical. So remember, probability is the number of favorable outcomes over the number of possible outcomes. So the total number of possible outcomes, there are 25 students and 5 students. So 25 plus 5 would give me a total of 30 students. We're looking for the students who are wanting to participate in the musical, and there are 5 students who want to participate in the musical, so that favorable outcome would be 5. 5 over 30 can be reduced or simplified. You can divide the top and bottom by 5 to reduce that fraction, and that would take me down to 1/6 as my probability. So 1 out of 6 are interested in that. The next example, Maya had a playlist of 20 songs. The playlist included 3 rap songs, 12 pop songs, and 5 R&B songs. If she plays the playlist on shuffle, what is the probability of an R&B song being played first? So again, this just says probability of R&B. You have your favorable over your possible outcomes. So this one tells us exactly how many songs she had. We don't have to figure up anything here. She has 20 songs on her playlist. And then we want to look and see how many of those are R&B. So there's 5 R&B songs, so that is our favorable outcomes. 20 over 5 is a reducible fraction, so we want to divide the top and bottom by 5. And so our probability that we would choose an R&B song with the first play would be 1 out of 4. In this example, we're going to find the probability in one of the rental parking lots at Rent and Save Auto. There are 5 trucks, 9 cars, and 1 van. What is the probability that they will randomly select a vehicle from this lot? And it would be a car. So the probability of a car. Remember, you have your favorable outcomes over the possible. So total possible outcomes. So this one, it does not give us a total, so we're going to have to add our 3 numbers here together. So 9 plus 1 would be 10, and 10 plus 5 would be 15. So there's a possibility of 15 choices here. And when you're looking at the cars, 9 of those possible options, the favorable option here would be 9 possible cars. So 9 over 15 is a reducible fraction, so you've got to always reduce. We're going to divide the top and bottom by 3. So that's going to take it down to 3 over 5. So the probability that you would randomly select a car from that parking lot is 3 out of 5. So we're going to look at a more complex problem with probability. You're going to look at the steps at the top as you go through the problem and think of those on your own. So our problem is Ross is going to toss 2 coins at the same time. What is the probability that both the coins will show tails? So when you're trying to make sense of this problem, some questions you could ask yourself is, what is this problem about? What are you trying to find out? And what information is important? So think about your answers to those. So our question is a probability question. We're trying to find out the probability that these 2 coins, when tossed, are both going to be on tails. And important information is the fact that there are 2 coins being tossed at the same time, and that you do need them both to land on tails. So step 2 is that you want to support your thinking and solve your problem. So that's what we're going to look at this point. So within our problem, if the first coin shows heads, what is the possible outcomes for the second coin? So we know the second coin is going to have to either be heads or tails. If the first coin shows tails, what are the possible outcomes for the second coin? Again, it's going to be heads or tails. So this thing says complete the table of possible outcomes with tossing these 2 coins. So here we had our 2 coins. Coin number 1, if it lands on heads, coin number 2 could also land on heads. So that's how we ended up with H and H. If coin number 1 landed on heads and coin 2 landed on tails, that's how we end up with an H and a T, heads then tails. So then when we complete for the second coin's possible outcomes, if our first coin lands on tails, then our second coin could also land on heads. So you could have a tails and a heads. Or if we landed on tails with the first coin, the second coin could also land on tails. So now you've completed your chart of possible outcomes, and the question for D is, how many possible outcomes are there? So when you look, each one of these is a possible outcome. So there are 4 of those. Of the possible outcome, how many are the 2 tails that we were looking for? So that would be a T and a T, and that's only this one right here. So that's going to be one of those were our possible outcomes that we were looking for. So explain how to find the probability that both coins show tails. So probability, remember, is your favorable outcomes over your possible outcomes. Our favorable is that it would be a tails and a tails on both, which is 1. Our total possible is 4. So our probability for that one would be 1/4. So as we connect and reflect on what we just did, we created a table to find our possible outcomes and our favorable outcome. You could have also done a tree diagram. This right here represents coin number 1. Coin 1 could have been a heads or a tails. This second one represents what coin 2 could have been. That first coin was heads, so the second coin could be a heads or a tails. And then if the first coin had been the tails, then you could have had a heads or a tails. So you can also do a tree diagram when you do these things to find out your possible outcomes and your favorable outcomes. All right, let's practice what we've learned. We're going to draw a tree diagram to show all the possible outcomes of tossing 3 coins at the same time. Then we'll find the probability of tossing exactly 1 head. So when we think about our problem is about the probability using 3 coins. What we need to know and what information is important is the fact that we are using 3 coins. We have to have at least 1 head. That is what they want, exactly 1 head, not at least, but exactly 1 head. So let's make our tree diagram. When you toss your first coin, you can land on a heads or a tails. So that's coin number 1. When you toss the second coin, it has that same option. It can land on heads or tails. And then when we toss the third coin, we need to branch off, and it also can land on heads or tails. So you're branching off each time for each coin you have, heads or tails. So this is coin 3. Had you had 4 coins being tossed, then you would need to branch off again. Just depends on how many coins. So that's the reason it's very important you read your statement. Now, what we're going to go through and look at is having exactly 1 head. So it can only have 1 H in the series. So when you look at this first series, it's H, H, H for heads, heads, heads. That wouldn't work. Your second branch goes a heads, and a tail, so it doesn't work. The next one is a heads, a tails, and a head, so that will not work. And then we have a heads, a tails, and a tails. That has exactly 1 H, or 1 head, so that would be a possible option. Moving on to the other branch, we have a tail, head, head, so that's not going to work. We have a tail, a heads, and a tail, so that would be exactly 1 H or 1 head. We have a tail, and a head, so again, exactly 1 head or 1 H. And then this last one would be a tail, and a tail. So to do the probability, probability is your favorable outcomes over your possible. Favorable outcomes is that we had exactly 1 head, so there were 3 of those. Possible outcomes is how many total options we have. We've got 1, 2, 3, 4, 5, 6, 7, 8. So our probability on this one would be 3/8, or 3 over 8, because that cannot be reduced. So your probability of having exactly 1 head when you toss 3 coins would be 3 out of 8.